All right, this is going to be AP Calculus, lesson 4-9. We are on triangular related rates. Before we get started, let's see where we are in our unit. We are done after this lesson, and then as a reminder, on Monday, that self-check 4-1 or 4.1 is going to be due. We're going to immediately start that day with just going over it, and I'm pretty sure, like 99% sure, that I'm not going to be here on Monday, which means you guys will have a recording and everyone is going to do that by themselves. Alright, so by the end of Monday, I expect 4-1 to be reviewed and then 4-2 to also be done in class and then reviewed as well online. Alright, so let's get to our lesson. This is going to be called the falling ladder problem, really famous problem in triangular related rate problems. So I had to start with this so that way we could write it down, and then we can get to it after we differentiate the Pythagorean theorem. So Pythagorean theorem, a squared plus b squared equals c squared. Let's take the derivative. So Joy, you're going to do that for us.
2a prime a, 2b prime b, same as c.
And yep, 2c, c prime. Perfect. You were saying a prime a, which is fine. It can go in either order. And then, so the trick here is I can divide everything here by 2 because everything has a 2 in it. So if I divide everything by 2, then my equation becomes a prime plus b prime is equal to c prime. Alright, and then of course another way of writing these, by the way, whenever I'm talking about triangular problems, a lot of the time they won't give us a derivative with respect to x. In this case specifically, it's asking for a rate, so this is going to be with respect to time. So this a is not dA dx. You normally have, like if I said y prime, you'd say, oh yeah, that's dy dx. That's not the case over here. Now if I have an a prime in a triangular rate problem, it's going to be something different, and here's what it's going to be. It's going to be a times a prime is still going to be dA, but it's not with respect to x. It's not dx, it is going to be dt with respect to time, which means all these are also going to be b times dB over what, Joy? dB over
dt.
Yeah, dt. And this is going to be c dc dt. All of those are with respect to time. You might ask me, Mr. Snell, why the heck do we even care if it's respect to x or respect to time? Can't we just leave it c prime and b prime? And the answer, in short, is yeah, it doesn't really matter, but I just want to make sure that you know that it is with respect to time when you're solving these problems. Because our units here are going to be, in this problem at least, it's going to be feet per minute. So let's go ahead and now solve our equation. We should probably have this guy boxed and starred. That's the main thing to take away from Pythagorean theorem in terms of its derivative. Let's go ahead and solve the problem now. So we can do like a little I don't know, little wave. Let us know that yes, we are indeed coming back to the problem now. So coming back to our example, and I'm just going to have to rewrite this on the next slide, so I'm not going to even continue writing this. I'm just going to move to the next slide. Let's erase all that. Okay. So, analyzing the problem, I'll write the variables on the next slide. We have what information? Top of a 10-foot ladder, and there's a vertical wall. So vertical, can you make your arm vertical, Joy? Vertical like that, yeah, straight up and down. So we have a vertical wall. Maybe I should do this in black because this is the example. So I have a vertical wall, and the top of the ladder is at 10 feet on that vertical wall. So we can say that the top right here, somewhere, well, maybe not at the top, this is going to be 10 feet. So our ladder initially starts like this, and I might have to make multiple diagrams, but there is our ladder. It's against the wall. And And I guess if I was drawing this with perspective, it should really be like the wall's there, and then the ladder is leaning against the wall with diagonals, but whatever. I think it's fine. Just there's your ladder. It initially has a height of 10 feet, and it's coming down at a constant rate of 12 feet per minute. Okay, so that's going to be a little bit hard to diagnose or hard to categorize as a variable. We'll come back to that in a sec. So the information that we've analyzed so far, 10-foot ladder, we have that information in our diagram. 10-foot ladder and a vertical wall, we have that in our diagram as well. So let's, and we're going to come back to the 12 feet. We'll underline that. When the top of the ladder is 6 feet from the ground. Okay, so let's go ahead and make another diagram. What happened now? So in our second scenario, our wall is still there, and now our ladder has slid down. So can you visualize what that's going to look like before I draw it? The ladder is sliding down. It doesn't slide into the ground. This bottom part is sliding horizontally out here, so it's going to make a triangle. So now my ladder looks like this. I guess if I were a better artist, I could draw this with perspective. But there's my ladder. It is slid so that the top of the ladder now is at 6 feet. So, and it's asking us, what is the rate of the change of the distance between the bottom of the ladder and the wall? So here's the key here. Oop, we should go back to red here too. The bottom of the ladder and the wall. So in my diagram, the bottom of the ladder and the wall, that thing, we need to find the rate of that distance. So we need to make our own variables, and I think I'm going to label this diagram here. Let's just go with A, B, and C. How about? So I'm going to label this A, B, and C. Now I can start making variables like I would for our last two lessons. So I can say, all right, so A, we don't know. I'll write what we do know. Sorry. So we know what C is. Joy, what is C?
10.
C is 10. Perfect. That is the height of the ladder. So even though the ladder is moving over here, the height doesn't change. So what else do we know? We know that it's sliding down in this up and down direction at 12 feet per minute. So what variable should we do, and what should we set equal to 12?
R prime?
R prime?
Or is it like distance prime? No, it's B prime.
It's one of these three letters, and I'll look at the question again. It's sliding down the wall.
Oh.
Down the wall. Which of those letters is down the wall? What is it?
B prime.
No. So that's
No?
not down the wall. This is away from the wall.
I said A prime.
Oh, you said A prime? Sorry. A prime, yes. A prime is equal to 12. Down the wall. And maybe, I think here, it might be better to classify this as a negative 12 if you want to say that's going down 12. Okay, what else do we know from our problem?
We know that the displacement is from 10 to 6.
10 to 6. So this 6 variable, what can we classify that variable as? In our diagram on the right, not the left one.
Oh, A.
A is equal to 6. Perfect. Okay, and I think that's all the information that we have. Now what's the question asking for? The rate between the bottom of the ladder and the wall. Bottom of the ladder and the wall. So what am I looking for?
B and
Careful here. It's just
Or
B,
C.
B prime.
A? Oh, B prime.
I'm looking for that rate. So that's our question. Okay, so from there, we're going to use our derivative of the Pythagorean theorem. So I'll rewrite that here as well. So we have our A prime plus B prime equals C prime. Now, before I plug in, I need to figure out what I can and can't plug in. Remember, there are 6 different variables here. We are looking for one of them. Logically, that means that 5 of these need to be filled in. The question then becomes, can we fill in all 5 of these? Do we know A? Yes. Do we know A prime? Yes. Do we know B? We'll have to find B.
So we can find it by Pythagorean's theorem.
Yeah, we can find B by Pythagorean's theorem. I agree. So let's I'm going to do that in just a sec. Let's continue analyzing. B prime, that's what we're looking for. So that should be our variable. C, we know is 10, and C prime. So we need to find B and C prime. Those are our two unknowns that need to be known in order to find our true unknown, our B prime. So as Joy said, we're using Pythagorean theorem to find B. We know that A squared plus B squared is equal to C squared. Plugging in A, B, and C, or plugging in A and C rather to find B, this is going to be 6 squared plus that unknown B squared is equal to 10 squared. And therefore 36 plus B squared is equal to 100. And if you already know Pythagorean triples and you're like, oh, Mr. Sindel, that's easy, that's 8, I know that, and that's fine. Subtract 36 from both sides and you get 64 is equal to B squared. And therefore B is equal to 8. Plus or minus 8, but you can't have a negative distance in this problem. So that's why I only chose a positive here. All right, now I have B, good. How do I find C prime now? C prime. Yeah, C prime. So C prime means how fast is this length here changing? Well, does the ladder change size?
Yeah. But oh
no. No, yeah, it stays constant. So therefore C prime is equal to what?
10.
It's how fast it's changing. If it doesn't change,
Oh, it's 0.
it's 0, yeah. So if the ladder is the constant means that this guy is 0 because ladder doesn't change distance or change size, whatever you want. I get that they could give you a really hard one and say that the ladder is also retracting because one of those fancy ladders retracting at a certain rate, and then we'd have a C prime. But in this case, it's 0. It is not moving. All right, so let's plug in. We have our A is 6. Our A prime is negative 12. Our B, we found down here, is 8. Our B prime, we don't know our B prime. That's what we're looking for again. That's our box. That's not a B prime, that's a B squared. B prime is equal to our C. We know our C is 10, and we know our C prime is 0. Perfect. All right. Negative 12 times 6 is what? I know it's a negative.
Oh.
6 times 12?
Negative 72.
72, perfect. Plus 8 B prime is equal to
0.
0. Okay, very nice. Therefore, 8B prime is equal to 72. And therefore, B prime, our thing that we were looking for, we have now solved it, is what? 72 divided by 8.
I don't know that. 17. Oh, God.
Oh, let's not complete my box yet because I'm forgetting something.
We forgot feet per minute.
Yeah, the units, which from the original problem were feet per minute. So what is this? Is this a distance? Is this area? Is this volume?
It's just distance.
Distance, yeah. And we can make a note on the side if we would like. So distance, come on, pen. Distance is always just units, nothing squared. Area will always be units squared, and volume will always be units what? Cubed. Perfect. And this is a distance, and it's a rate, so it's going to be divided by time. So this is going to be 9, and as we saw up here, it's going to be feet per minute. So I come over here and say feet, come on, pen. It did that weird thing again. Feet per minute. And there's our answer. Okay. So I do have another type of problem, because there's really only 2 types of problems that I know of, and I would like to go through both of them. I know that that kind of limits us on our time because we get out of here at 10:10 and is currently... No, we have 14 minutes. All right, so let me go ahead and grab... I forgot to do this first. Command C, and I need to add a new slide. Command V. Okay. So another writing problem. I apologize. So the travel problem. All right. So we need some character names. Should we use someone in our class or what? All right, we'll say Tony and okay, Joy. Sorry, you are now in the story. Tony and Joy are in motorboats located at the center of the lake. I'm gonna say Joy, you can start this. Joy begins traveling south at a speed of 32 miles per hour. At the same time, Tony, maybe we can spell Tony with an I. No, we'll leave it Y. Tony.
It's Tony the Tiger.
Oh, Tony's definitely spelled with a Y then. So Tony takes off heading east.
South is supposed to be capitalized.
Oh.
East is also supposed to be capitalized.
East at a speed of it's hard to see from the notes, so I'm gonna go ahead and say 7. And then the question here is, at what rate are they separating after 2 hours? Oh, it was supposed to be 27, not 7.
Oh my God, that just ruined everything.
They ruined everything, I'm sorry. Alright, so just like we did last time, we probably need to start by drawing a picture. Alright, so let's say there's the center of the lake. Oh, I should wait until you copy down the problem, maybe.
It's big.
Okay, so that is the, we'll say that's the center or the start, the center of the lake. And I'm gonna grab my little line tool and say that, so Joy's going south. So here you go, Joy, going south at a speed of 32. So I guess we need some variables in here. We'll eventually get that. And then Tony's gonna head east, so we'll make Tony black. Tony the Tiger goes this direction. I guess the red line really should be bigger because it's going faster, but whatever. It's all relative, man. Just so happens if one goes east and one goes south, then you have this cool little right triangle. And it's asking for the rate that they are, oh gosh, separating. Come on, Mr. Sindel, separating after 2 hours. So it's asking for this distance between that two endpoints after 2 hours. That lake must be really big, I'm realizing. So this is the length that it's asking for. And I'm going to do this as a dash line because it's this imaginary distance between Joy and Tony.
The displacement.
I don't think displacement is the correct idea. or the correct word to describe it.
But it's physics
Because displacement usually is in an object going one direction. This is the distance between two objects as they're both traveling. Alright, so we're really trying to find that. Let's go ahead and label this guy. We'll say A, B, and C. So what do we know? Sorry, before I keep on writing, let's read this. Joy travels south at a speed of 32. 32, okay, so speed of 32 south means what is what? What is equal to 32? A prime?
Yeah.
Yep, okay, A prime is 32. At the same time, Tony takes off heading east at a speed of 27. So what is equal to 27?
B prime.
Yep, B prime. And at what rate are they separating after 2 hours?
C prime.
Prime, yep, there's our question. Alright, so we know our equation. Our equation looks like this, and I'm going to put it off to the far right because there's going to be a few steps that we need in order to find this. So it's going to be A prime plus B prime plus C prime. Oh, what? No, that's not it. Equals C prime. Okay, what do we have? We have A prime, B prime, trying to find C prime, which means we need to find C, B, and A. We have 3 things we have to find.
Plug in 2 miles per hour.
Plug in 2. Why are we plugging in 2? Oh, 2, yeah, 2 hours. We haven't used that information yet. So somehow we're going to use this 2 hours to figure out A, B, and C. Well, let's think about this. So 2 hours of traveling 32 miles per hour. This is just a straight-on Algebra 1 problem. Or maybe even 7th or 8th grade. 2 hours and 32 miles per hour. So let's do the math over here. So if my speed is 32 miles per 1 hour for 2 hours, this is going to be multiplied by 2 hours. Notice that hours and hours cancels out. Alright, so the hours and hours will cancel out. Okay, I should try to go like this. Hours and hours, and I just have miles. And how many miles have you gone in those 2 hours?
30. No. 64.
64 miles. And what is equal to 64 now?
That's 8.
Yeah, so A is equal to 64. Perfect, okay. And let's work on B. So B is going to be 27 miles per hour, so 27 miles per 1 hour times 2 hours. Hours and hours, again, the units cancel out. And I'm left with B is equal to...
27 times 2.
Yeah. Yeah, just do that. 54. And how the heck are we going to find C?
C doesn't change.
C will change, yeah, because they're getting farther and farther. Yeah, it's not like the ladder problem, sorry.
Pythagorean's theorem.
Pythagorean's theorem, exactly. So, running out of room here, I can do it off into the side margins. So if I have a triangle, I should maybe make this lower so it makes sense. I have a triangle here that is 64. It doesn't really matter which one goes where, but we'll say the 64 by 54. I need to find that. I guess I should just call it C because that's what it really is, C. And knowing your laws of similarity from geometry, you can actually reduce that triangle by some scale factor and then scale it back up after you're done. So you see that all this can be divided by what?
2.
Yeah, let's just do 2,
6?
right? Yeah, 6 will not work. 4, 54 is divisible by 4. 64 is not... Oh, it is divisible by 4. You're right, yeah. Let's divide both of them by 2. Or by 4, sorry. So 64 divided by 4.
It doesn't work for 54.
Doesn't work for 54?
No. Because then it's like 14.
Ah, you're right. Okay, so 4 doesn't work. Let's just do divide by 2. That's going to be 32 by 27. And 32 and 27, are they co-prime? Can you not divide them any farther?
You can't.
Ugh, that's gross. Well, I thought it would simplify a little bit more, but it doesn't. So we can just scale it back up by a factor of 2 when we're done. So this is going to be 32 squared plus 27 squared, and then we'll multiply by 2, that scale factor. Or, yeah, it was by 2. Okay, so our 32 squared plus 27 squared. Okay. I'm going to cheat here and use a calculator because we're running low on time. We have like 2 minutes left. 32 squared is 1024. So 1024, and 27 squared is 729. So plus 729. And that is going to be, so that means we can write it out here, that C is equal to the square root, because we have to...
Would it be 2C? Or is
Oh, yeah,
it
sorry.
divided by 2?
Yeah, let's go ahead and say, 2 times the square root of both of these added up, which is going to be 1,753. And for other girls looking at the notes, that might be written as the square root of 7,012, but that's because you didn't factor out a 4 to get the 2. All right, so now we have all of our variables, and we need to plug in. Oh, fun. Okay.
What's the square root of that?
Square root of 1753. I don't think it's a nice number. 41.87. Oh gosh.
What's 2 times that?
Oh yeah. So let's just do 2 times square root of 1753, and that is 83.74. 83.74. All right. And so that means plugging in, I think I'm going to have to plug in on the next slide. So plugging into my equation, I thought I would have room. A prime plus B prime equals C prime. All right, A was 64, 60, I should probably just do blue here. 64 times A prime was at 32?
I think so, yeah.
Plus, and then it's like 74 or something like that. What is B? B is 54, 54 and 27. 54 and 27 equals, and then that redonkulous number, 83.74. 83.74 C prime. All right, and then all you have to do is multiply those together and divide by square root of 712, essentially. So I think we can just leave it as the square root of 2 times square root of 1,753, and that's okay. And the end of class just happened, so let's go ahead and finish this really quickly. So 64 times 32, 2,048. 1,048 plus 54 times 27 is 1458. 1458. And I'm just going to leave this as 2 radical, all of this, 1753 to get an exact answer. 5. Oh, come on now. 1753.
Doesn't that mean you have to multiply both the bottom and top by square root of 1,005?
Kind of, yeah. So that means, so we have 3,000. What's this going to be? There's a 6, carry the 6, that's going to be a 0, carry the 1, it's going to be a 5. 3506, is that right?
I have no idea.
3506 divided by 2 square root of 1753, that is equal to our C prime.
Then we can't have a square root on the bottom.
And you can't have a square root on the bottom, exactly. So you have to multiply, 3506, if you divide that in half, oh man, mental math really quick, what is that going to be? It's going to be 1,053,
It'll be 2,000. Oh shoot.
like that. Oh, I'm off. Because that's going to be 25.
It'll be 3,000. 3,500 and 6.
3506 1753. No, I got it right. 1753. All that divided by square root of 1753.
It cancels out.
C prime. And I need to multiply the top and bottom by 1753, and you're right, yeah. So if I multiply by square root of 1753 over 1753, then this becomes on the top 1753 times the square root of 1753. All this divided by square roots will cancel out, and I'm left with 1753. What is going on? 1753. And then these guys will cancel out, and you are left with your final answer of square root of 1753 is equal to your C prime, and therefore C prime is, we approximated that earlier, is 83.74, and our units again were miles per hour. Miles per hour is equal to C prime. All right, that's all I have. Go ahead and write your summaries, and then make sure that you do the self-check 4.1 before you come to class on Monday. A reminder, I'm not going to be here on Monday, so be ready to watch videos and do stuff on your own. All right, see you.